We stopped at this point on this slide where we looked at the classification of hazard waste characteristics. And we said they could exhibit different characteristics as indicated based on the hazardous waste explosion, oxidizing, organic peroxide, poisonous, infectious, corrosive, and they can be flammable. Flammability of this waste could be in any form, as whether solid, liquid, or gaseous. It can emit flammable gases, that is, the hazardous waste can emit gases that can ignite fire easily, impact health hazards, and then can also be infectious, can be toxic when in contact with, and then it can cause a spontaneous combustion, and that is causing or resulting into flame spontaneously or naturally. Then we have the physical hazards of hazardous materials. Types of physical hazards associated with these materials could be oxidizers, which are also capable of causing degradation in materials by a way of reacting with oxygen in the environment or other substances that can be reduced as a result of the oxidation. The oxidizers can induce oxidation, and in the process, the substance that is being oxidized we also have a corresponding reduction in its properties. Flammable explosion, corrosive to metal, and high pressure system. You can see the symbols, the international convention symbols that are indicated here in order of the names as indicated. If you see the first one, you see a symbol like that is indicating that the substance you are dealing with is oxidizer. You see the second one, it indicates flammability. Then the third one indicates explosion, corrosion, and then high pressure are indicated in the last two respectively. So we move on to the next. I think I put it on slideshow, which can give us a better view. Can you see this better? Is it better for us?
Yes, sir. It's better now.
All right, fine. So we'll go ahead with this view. So next we are talking about hierarchy of controls, controlling physical hazard. There are ways that can be used to control the hazards associated with substances. The physical hazard can either be eliminated, which is the most effective and most desirable. So you can see the triangle here. It's
No audio again. It's like network has knocked him out.
Yeah, sorry, there was an audio loss due to network fluctuation. And I think that has been taken care of now. Can you hear me now?
Yes, sir.
Yes, I can hear
All right,
you.
thank you.
Yes, sir.
One of the challenges associated with this technology, sometimes you have these connectivity issues. I miss the advantages that we enjoy taking these lectures at an inconvenient end. So I was talking about substitution as a second option in order of preference. Then we have the engineering control, which somebody check your microphone so that you remain muted to avoid background noise, like the baby's voice that we are hearing, please. And just check your microphones. Then we have the engineering control, which requires or involves isolating people from the hazard. If you have a technology that is capable of shielding the people from the hazard associated with that, is the next alternative. Then change the way people work. This is attitude. The attitudinal change here requires that people are conscious about the hazard associated with these um, substances or environments and take precautions to avoid them. That does not serve as much as eliminating or substituting or having an engineering control, but is better than just the use of personal protective equipment. And the least is to use personal protective equipment. And if you look at this, in most instances, it depends only on the personal protective equipment. But from this explanation, you know that that is the least, the one that gives us the least result as controlling the hazards associated with this. So we should not depend solely on that. While we use it, we should also be conscious of and the precautions we will take as our own approach to those things. Elimination, I explained that while looking at the chart, it's just the explanation put in writing or further explanation as indicated in this. I've talked about the preference, the order of preference in the use of these alternatives. So these are just further explanations to that. Now, we move on to the next, which is chemical hazard. This is just an example how these things can be identified, chemical hazard identification system. So if you look at some containers, this information are indicated there. For example, health hazard. Number 4 gives us the information that is deadly. Extreme danger is number 3, and we are given example as indicated. Normal material is indicated with the use of the number 0, and then sometimes these abbreviations are used to indicate that. That is for health hazard. You have 0 for normal material, slightly hazardous for 1, and then hazardous for 2, and extreme danger 3, and deadly. If we come to fire hazard, flash points are indicated as shown. These numbers are also given specific temperature ranges within which they are defined. Then for instability of chemicals or substances, they are also defined in this on this scale from 0 to 4. So when you talk about something being unstable, it can go into reaction by itself because of the internal energy it possesses. So when we have 1, when we have 0, we are saying that that particular substance or chemical is stable, and then unstable if the number is 1. Violent chemical change can occur if the number is 2. Shock and heat may detonate when the number is 3, may detonate when it is 4. Then the labels are there as indicated. Moving on to the next is the hazardous waste management. The best method for deciding on the hazardous waste, this is a class of 31, I think you said 31 as the total for the class. We are having about 22 or 22 in the class, fluctuating now to 21, and then excluding myself and possibly the host or the Zoom admin, we may be talking about 20 in the class. If you have some people that are yet to join that you may call on them to join. It is good to share in the class, not just to depend on the access to the material. Then hazardous waste management, best method of deciding on the hazardous waste management is by using the waste management hierarchy, which is what we have just discussed in the previous slide. This method is intended for decision-making which addresses issues like sustainability, cleaner production, health safety, and environmental protection. It is applied to existing or proposed practices, examining and testing these at each level, starting at the top of the hierarchy. We looked at that. Is it possible to remove the production of hazardous substance or material or waste? Is it possible to reduce the quantity or hazard involved where elimination is not possible? So these thoughts are dealt with in the course of hazardous waste management. And then what is the difference between reduction in the quantity of hazard and also in hazard itself? The hazard quantity may be the quantity of the substance available that is hazardous. Then the reduction in hazard that is involved is a way of reducing the intensity or the gravity or the potency of the hazard that is there. For example, if you have a concentrated acid, it's very hazardous. Remember our discussion yesterday when we distinguished between hazard and risk. The potency, the potential to cause harm is what is referred to as hazard, while the degree of exposure to the hazardous material is what is called risk, in summary. So, if you have a concentrated acid, for example, it is very hazardous. But by the time it is diluted, but still with a tendency or potential of causing harm, it is then we can say that the hazard involved has been reduced. Even though in this case, you may see that the quantity of the acid may increase because of the dilution, because of the solvent that has been added for the purpose of dilution, but the hazard involved is reduced. So this is an example to distinguish between reducing the quantity of hazard or reducing the hazard involved. Reuse, recycle, and recover by minimizing the amount of waste. Minimizing the amount of waste by improving existing technologies. We can improve on technological approaches in a way that can give us less hazardous waste products in the course of our production processes. Treat waste to stabilize, immobilize, contain, or destroy hazardous properties. Waste treatment to be able to reduce the tendency of that waste to cause harm. And if you looked at um, the rating, the scale for this 0 is indicates stability. So if you are able to, and then the ones that are unstable have higher value. So if you are able to make a waste product stable, then you have reduced the hazard associated with it. Dispose the residue in an environmentally friendly manner so that it does not pose harm to the environment. Then we move on to the next slide, which talks about hazardous waste management. And then we have the another pictorial presentation there, which gives us the order of management in a triangular form. This is also from the least to the most preferred. If you are able to remove it, don't generate waste at all. That is, you have removed the hazardous waste. If you don't generate a hazardous waste, and the way to do that, as I've said, if our technologies, production processes are improved in such a way that such waste uh, are no more generated, then we have achieved the most desirable option. Then reduce the waste that is generated. Generate less waste by better management and material substitution. So if you know that this particular process generates more waste that are hazardous to the environment, think about the alternative materials or alternative technology that can generate less. Reuse. When waste is reutilized in another way as a raw material, its own availability in the environment is reduced. confirm that we are together? Is there a point you lost audio or what I'm saying?
Yes, sir.
Yes, sir. For
There's
over,
a point
For
for
a
over
very
5
long
minutes.
time.
a long time.
Yes,
Yes,
sir.
Yes, long
And
time.
your screen has gone.
Up to now is off.
Yes, sir.
Yes.
Oh, that is sorry. And did any of you try to communicate that to me? Was it not possible for any of you to unmute
Sir,
and say something?
sir, you were out of the system completely.
Okay. That was not visible at my end. So let me take you a bit back. Did we discuss this together? This slide that is, can you see my slide now?
yes, sir.
Yes.
Sir,
We
we
are
can
no
see your
more
slide now.
hearing you again. Thank you
We
for
can
this
see your slide.
information. This information came in about 28 minutes to 10. That is 9:31, 9:32. So just a few minutes ago. We are back now. We were on this slide together, isn't it?
Yes.
I'm
Then
done with
how
it.
about this?
No, we only waste management.
Huh?
We
Let,
hazard
let me
waste
go through with you.
management.
Okay,
Yes.
hazardous waste management.
Yes.
Did we finish this together?
No.
It is one.
All right.
This, yeah,
Okay.
this is where we
And then
are.
this is with the next one. This is the next one after that one. So you lost visual view of this and also the audio part, isn't it?
No,
Even
sir.
the previous slide.
Okay.
This
You
exact.
you were
Yes.
up to this point.
Yes.
Yeah, this is where
Okay.
we are.
Okay, fine. Let me just take up and go over this one briefly again. I said that
Okay.
this is a hierarchy of waste management, and it is this triangle presents the stages in order of preference from the least to the most desirable option. The most desirable is that you should be able to remove the hazardous waste. That implies that it shouldn't be generated. So when that is to happen, it means that we may either utilize better technologies that we ensure that such waste is not generated. And the alternative is that we will also use better alternative raw materials that can give us such results. Then reduction in the waste that is generated can also be an option if it cannot be removed completely. And this reduction also has to do with use of alternative material or improvement in technology. While the next one is reuse of the generated waste as a raw material for production of another usable product. Then it can be recycled, it can be recovered, can be treated, can be disposed. Then I said disposal is the last option as indicated on the chart. But before disposal is done, treatment has to also be considered so that the it will not just be a mere transfer of hazard from one location to another. It should be a way of reducing the potency of the hazardous waste and keep such that to wherever it is discarded, less impact on the environment will be experienced. So what is on the left beside this, the chart is just this explanation that I have offered. And when we relate this to the previous slide, we discussed about the rating of the hazard, where on the scale of 4, we look at some being stable, unstable, and then tendency to detonate. We can see that as part of treatment, the hazardous waste can be made to be stable, to be stabilized, and then it can be immobilized. Immobilization is a way of causing this not to migrate in the environment freely, and then also destroying the hazardous properties. Are we together? Hello? Are we together?
We are together, sir.
Yes.
Yes, sir.
All right,
Yes.
fine. So we move on to this one, and then I'm talking about having looked at ways of minimizing or controlling hazardous waste. There is an option that these waste will eventually be transported, and there are transport requirements. This is what is presented in this table. And transport permit should be available for those who are licensed, establishments that are licensed to transport this, so that the technical requirement, the professional requirement, and the facility that are required are assessed and recommended or approved as being adequate for the purpose. And then I gave an example that you may see that sometimes in the common knowledge about transportation of waste from one point to another, you see a conveying vehicle rather spraying that along the path because of lack of professional handling of the waste material. This could be common sight that some of you have experienced in different cities, where the vehicle that is conveying the waste from the dump site or from the communal bin to a designated disposal site will rather be spraying that on the road, such that sometimes vehicles that are behind such a vehicle find it difficult to find their way through while that moves. So if for hazardous waste, if that happens, then it is a way of distributing hazard and then causing more health challenges to the environment. Then collection schedule should be there so that one knows particularly when such is to be taken away. And that gives a better, that can be done as a way of preventing accumulation of waste at the waste collection point. And also with a good knowledge about the waste generation capacity within the area. Then vehicle capacity has to be considered as well. How much of this can be taken at a time by the vehicle. Then the vehicle must have a clear sign indicating the type of waste that is transported. Safety equipment have to be there. I talked about protective, personal protective equipment, and as well as uh, hazard response materials or facilities, such as fire extinguishers can be available because some of these hazards associated with the materials are combustion and related things that can generate heat. So when that happens, you may have to do your own part as a first response. So these are some of the requirements that are expected about the transport of hazardous materials. So officials that are involved should be trained personnel, and then even the driver should be a trained personnel that will be able to know exactly what to do in any emergency situation. There could be a requirement for storage of the hazardous material. It is not always, just as I've said, these things have to be conveyed or taken from a point. And within that time, there should be proper storage system for preventing that to be accessed by unauthorized person, and also for shielding people away from the hazard associated with them. The storage area should be away from public places in order to prevent any harm. That is part of what I said. Access to storage should be prohibited for unauthorized personnel. This is clear because there are precautions that have to be taken, and there are also uh, um, protective equipment that have to be utilized by such people that will access such materials. The container should be of prescribed property. For example, being inert to the hazardous material, so that the container doesn't serve as um, um, a reactant to the contaminant, or to the hazardous material, to generate another reaction that can produce undesirable results. Then we move on to specifications. Hazardous waste storage containers must be of inert materials which do not react. I've discussed this before. I mentioned this. There should be clear labels giving information about the danger associated with this. The waste generator is responsible for maintaining the containers clean and wash them after use. Hazardous waste treatment can also be required, or may also be required at certain times. When this waste is to be disposed, as I discussed before, there might be a time that it should be reduced to a friendly or a relatively friendly substance or waste that can be disposed of in the environment with less negative impact on the environment. The purpose of treating hazardous waste is to convert it into non-hazardous substance, or to stabilize or encapsulate the waste so that it will not migrate and present hazard. Well, this is part of what I've said. And this treatment method can be uh, generally classified as chemical, physical, biological, and thermal and biological, which will come in different ways. We have thermal and land filling. These are ways of treating the um, hazardous waste, or disposing the hazardous waste. These are briefly described as indicated below. The chemical method includes neutralization of waste acid with alkali. You know that from our common chemistry knowledge, a reaction between an acid, which is also a dangerous substance or a corrosive substance, with a base, which can also be corrosive, brings us a product that is neutral in nature, a salt. And this has less effect on the environment. So if you have seen that a particular hazardous material has acidic property, you can react with it an alkali, which neutralizes the acidity of that particular substance. Then oxidation, oxidizing substances, or such as hydrogen peroxide or hydrogen hypochlorite, can reduce the effects of substances which are in their high oxidation state. You know, oxidation is is a chemical process and requires a change in oxidation state. And then oxidation changes the oxidation state of a chemical substance from low to high. That is oxidation. And then reduction changes that to a lower level. And chemical reactivity is related to the oxidation state of certain substances. There could be the same material, but because it is in a given oxidation state, it may be less harmful. Take, for example, conversion of inorganic substances to less mobile and toxic form, e.g. reducing chromium 6 to chromium 3. biferrous sulfate. It's a way of reducing the, the hazard associated with chromium. It is the same chromium that is found in the environment, but because with a varying or a different oxidation state, its own harm to the environment will also be reduced. Hydrolysis, which involves the decomposition of hazardous organic substances, can also serve as a way of reducing the hazard. Then precipitation stroke flocculation. These are various ways that this can be treated, and they are explained here. Physical stabilization or solidification. I mentioned that. Why do we talk about solidification as a way of stabilization? You know that reactivity of substances is related to their to the surface area. The more the substance is in fine state, the more its own surface area for reactivity. So when you have something in powder form and then it is made to, or in powder form or in liquid form, then it is made to be in a more solid form that its own surface area is reduced, then its own reactivity or impact on the environment is reduced. Sedimentation is also one of them. Solvent extraction and the ion exchange process. Solvent extraction is a way of separating the impurities of a liquid by contact with another immiscible liquid. And by this, the properties, the components that are required to be separated from the solid waste that can reduce its own toxicity are taken away from that substance before they are disposed of. Then we move on to high temperature incinerators. We discussed incinerators yesterday, but there are certain incinerators that exist or operate at very high temperature degrees Celsius or Kelvin temperature. So such it serves as a way of destroying certain hazardous waste materials, especially, for example, destruction of polychlorinated biphenyl can be done by this. It involves converting the waste material into ash. We discussed the product of combustion or incineration yesterday, and we saw ash as one of them, and then conversion into heat. And we saw yesterday that the proper utilization of product of incineration can give us another alternative source of power generation or energy generation. So when this is done, heat can be generated, which can be utilized for meaningful purpose. Then we have other consequences that will come out as pollutant. There could be particulate matter that will be released into the air. But the difference is that by this point, these are not as poisonous as the initial product. So it serves as a way of managing the hazardous waste material. The advantages of the incinerators are the degree of waste quantity that can be handled at a time, the efficient waste management, and the production of heat and power, reduction in pollution through trapping pollutant by bags, filters, and scrumbers. I said part of this yesterday as the advantages of incinerators. The disadvantage of this is in its cost, very intensive in the operation and even in the installation. So when operation and installation are all of high cost, then they become a big challenge as a disadvantage to this particular option. There are other dedicated sanitary landfills for hazardous waste. Hazardous waste can be discarded in specific sanitary landfills, which are designed specifically for this purpose. When this design is done, it takes into consideration the nature of substances that will be discarded, and the encapsulated materials are used before placement in the landfill. So precautions have to be taken so that in the course of um, discarding this in the landfills, the host environment is not endangered by the properties of this hazardous waste material. Modern refuse landfills have a role in the disposal of residual from treatment processes and possibly limited disposal of hazardous waste with normal refuse. This requires a level of management of these landfills considerably in excess of what in excess of that practice at refuse dump in the past. So there are professional practices that are required in this process, not just as dumping waste in the open dump site. Then we have hazardous landfill schematic here, and you can look at its design. This is just giving us the basic component of that. As we saw in the other design, we have a gas vent, the topsoil, the earth, and the sand. Layers are created so that there could be proper shielding of the environment from the possible hazard from this hazardous waste. And you can look at the component as designed. And groundwater, the water table is always of concern. How much of this can infiltrate into groundwater? There is a careful consideration to prevent that, because once that happens, a wide range of life is exposed to danger, both of human and animal. And it is also possible to give it a widespread through the flow of water. Definition of wastewater. It is simply water that has been used. It usually contains various pollutants depending on what it was used for. It is classified into two major categories by source, and this the what do I call domestic or sanitary wastewater, and then the industrial wastewater. And as the name implies, these ones come from municipal areas. The domestic include the municipal residential sources. Then the industrial comes from industries or establishments concerned with manufacturing and production or commercial enterprises. So these are separated because by virtue of the usage of water, their own composition will vary and will be in line with the type of use that is employed. Wastewater in urban and rural areas. Most urban areas with sewers first used a process called primary treatment, which was later upgraded to secondary treatment. Some areas where needed employ advanced or tertiary treatment. All this depends on the type of end use that is intended of the wastewater. Rural unsewered areas, for most part, use septic system. In this, a large tank known as septic tank settles out and stores solid, which are partially decomposed naturally by naturally occurring anaerobic bacteria. The solids have to be pumped out and hauled by tank truck to be disposed of separately. Sometimes this can be used as a raw material for production of fertilizers as well. Liquid waste are dispersed through perforated pipes into soil fields around the septic tank. These are some of the experiences, some of the things that you might have been a witness to before. One of the largest sources of wastewater is that which comes from homes and industry. And industrial wastewater contain toxic substances which endanger human health. And some examples are given as the pesticide, the polychlorinated biphenyls, heavy metals like lead, mercury, and nickel, and a host of others. The goal of sewage treatment is to remove all of these pollutants from the wastewater, but this cannot be removed at one stage. That is why we have classification of the stages of wastewater treatment or of water treatment, even water treatment itself. When a primary treatment is done, it moves to secondary and tertiary. This categorization has to do with different degrees of treatment and then specific pollutants that are removed at various stages. The point source, wastewater is usually divided into two major groups, which are point source wastewater and non-point source wastewater. Point source wastewater includes wastewater that enters natural waters from defined location. When we are talking about point source waste, we are talking about a wastewater with a known source of discharge. Then it is released into the natural water body like lakes, rivers, and ocean. But a non-point source wastewater is the one that is not connected to specific source. For example, when there is a rainwater runoff. Hello, class, are we together?
Well,
Hello, class,
sir.
are we together?
Yes, sir.
Oh, thank you for confirming that. Thank you for confirming that. So, for example, when there is rainwater runoff in the within an area, the water that falls as rain flows as on the ground and gathers all sort of waste from any corner that it flows through. By the time you get runoff water and measure and get certain pollutant in it, you cannot say that this pollutant is coming from here, this one is coming from here, because definite no specific sources are indicated from the gathering that has been made up from the runoff. But for example, if you go to waterworks, for example, it treats water, water is treated and the wastewater sludge is redirected into the river. Then you go to that discharge point and then you make an analysis, take a sample and analyze. Then by the time you get the result of that analysis, you know that this is what is discharged from the waste product. This is the properties associated with the waste product of water treatment plant that is discharging into. So you can see this as an example trying to elaborate more on the distinction between point source and non-point source waste water. Then, why wastewater should be treated? There are good reasons to do that. It is a matter of caring for the environment and for our own health. There are a lot of good reasons why this should be done. Fisheries in the water, and plants in the water, and other animals in the water also require a good water environment for survival. So when pollutants are discharged into the water to a degree that is harmful to them, then the life in such environment is affected. Therefore, we have to be conscious of that, and it justifies the reason for treating water. Wildlife habitats also are to be considered because of the negative effect of this on their existence. Recreation and quality of life. The water body can be used as for recreational purposes. And when the water that is for recreation is not in good or in high quality standard, then it exposes the users to health challenges. Then the general health concern is one of the reasons why this has to be treated. Then basic characteristics of wastewater are indicated in this chart. And I've said there are what we call the physical characteristics, the chemical characteristics, and then the biological characteristics. Examples are indicated here. And when you look at these examples, they are not limited to, the properties are not limited to this example, but there are some out of many that can be used under these properties. Then we have the overview of wastewater, general overview. Sewers are designed to provide wastewater velocity of at least 0.6 meters per second. Because the wastewater in collection system moves relatively fast, the solid stays in suspension. Because the velocity of water is high, what happens? It does not allow the particles to get settled. So that is why you see the particles are left in suspension. And that is why when you have a high speed water current, you will see that most of the, in an environment that the water is polluted, you see the water looking so turbid. When the water becomes still, when the current is not high, you see that the water that was very turbid becomes relatively clear. This is because sedimentation has occurred. The particles um, uh, have been able to go and settle at the bottom. And when that happens, you look at the water as if it is clean. But when the benthics, when the bottom of the water body is disturbed, such a suspension comes out. So the current of the water also it gives idea or explains why particles may or may not settle at the bottom of the river. This is also presented here. It's unfortunate the diagram is not as clear as you may for you to see very well, but I think by the time you have the slide and look at it better, it gives this. We have the primary clarifiers. This is settling of the biological section for this, the disinfection unit, and then we have the secondary clarifiers for the treatment, the outflow, and these names are indicated against the sections that are involved in the wastewater treatment. The types of wastewater treatment is also to be considered. And here we have what we call the sewage treatment, which involves three, let me just look at my battery level. Yeah, that is fine. Involves three stages: the primary, the secondary, and the tertiary. The primary treatment physically separates the solid and liquids. At this time, the large particles, the debris are taken away from the waste. The remaining water is left to stand in a tank where smaller sediments or particles of sand, clay, and other materials settle to the bottom. That is a process known as sedimentation. These sediments are called sludge. At this point, the liquid part of the wastewater still contains many pollutants and is not safe for exposure to human or the environment. That is the primary stage. It does that, but the water still remains unsafe. Then the secondary treatment, which is the next step, involves the part of the liquid of the waste to pass through a trickling filter or an aeration tank. At this stage, small holes in that dribbles water over a bed of stone or corrugated plastic. Bacteria in the stones or plastic absorb pollutants from the water and break them down into substances that are not harmful. This is the biological component that is also involved in the wastewater treatment. Aeration tank is a tank that contains bacteria that break down the pollutant. The liquid part of the wastewater from primary treatment is pumped into the tank and mixed with the bacteria. Air is also used through the tank to help the bacteria to grow because they need to survive as living organisms to do their work. The sludge is removed from the bottom of the tank after the process is after a given time of the process. It still contains high concentration of nitrate and phosphate. Phosphate minerals that can overstimulate the growth of algae and plants in the water. This can be handled by tertiary treatment. It is the next stage that is capable of removing that. You can see that depending on the type of use, water may be used as secondary after secondary treatment, and it may also be used after primary treatment. But a higher quality of water to be obtained from this is done after the tertiary treatment. Then you look at the pictorial flow chart of wastewater treatment plant, where you have the wastewater coming into the to a level of screening, and then drift chamber, primary sedimentation tank, aeration, and all of this. As I've said earlier on, some of you in this class might be professionals in this area, might be practitioners in this area, as well as professionals in the area. You will have to relate this pictorial presentation with what you do in your practical experiences. Now, we move on. Yeah, there was a slip of this, and I move backward. So this is what is presented in this chart. Now, primary treatment has also been explained already. It's just a deeper explanation, what happens at that level, the components that are taken out as part of what I've explained. Flow from the sewer enters the screen, and which is what is indicated in the flow chart. The bar rags to remove the large floating materials such as rags and sticks, knives, paper, and plastics. So it then flows through a grit chamber where heavier inorganics materials such as sand and small stones are removed. So it is just a stepwise explanation of what I explained while presenting the pictorial there. Wastewater treatment plant flow chart. Then you look at what happens at each stage. From the wastewater that is generated, there's an influence where we consider as the introduction point of the waste into the waste treatment plant. Then primary treatment takes place, primary clarifiers are there, and then you see the connection between this, the aeration tank, which has enough air to be introduced in it for bacterial activity and also for removal of odor. Then you can see a connection from the secondary clarifier. It is possible for this thing to go back and go through the aeration tank depending on the quality that is obtained. Activated sludge is there and recycled. So when this process is repeated to a sufficient level that the secondary treatment produces water that is of quality that can go forward, disinfection takes place, and final effluent is discharged. Then you can also have from the secondary clarifier the waste activated sludge, which is the one that may go back to the sludge treatment and disposal. So from here you have the effluent, the liquid discharge, and the semi-solid component, which is known as the sludge. While the effluent is disinfected and discharged as liquid, the sludge may move on to the sludge treatment unit and be treated and disposed of. This is what has been explained, the secondary treatment unit, and then they state the percentage of pollutants that are removed at this level, and then the basic processes that are involved, which variation of what is called the activated sludge process. Then we move on to the next, which shows us the schematic of the secondary treatment flow chart. This has a component of the primary treatment, connecting the fact that after this secondary treatment receive products of the primary treatment. That is why, if you remember from the previous one we saw that effluent from the primary treatment, and you can see effluent here now moving into the secondary treatment chamber, and that process continues, and then you get disinfection of the product again, and that is also discharged as the product of secondary treatment. This secondary treatment product can also be subjected to a higher treatment level, which is the tertiary one. But depending on the use, as I've said, it might also be taken here as the final product for use, as may be desired by the properties and usage intended use. Then we have aeration tanks. Just as I'm mentioning these components, there are some of them that when you take them of their own, you have a more detailed explanation, and then exposure to the content. They are just summarized in the bigger scheme, but each of them can be treated in detail to look at what is involved, the components, and then the detailed processes that occur in them. So this is just a large-scale aeration tank presentation. Then secondary clarifier also presented here. And this is something that if you go to a waterworks, you will see this unit. Just as designed here, water moves at a point from one unit to this point. And then I think from fluctuator that it moves into these clarifiers, and then from here it proceeds for further treatment involving filtration before it moves into the storage tanks. So these are separate units that are involved in the treatment process. Disinfection occurs after then, and disinfection can be done through chemical application or application of radiation within the specific spectrum range, within the specific spectrum range. And that is why we are using UV, ultraviolet visible is preferred, because chlorine is hazardous and difficult to work with. So in the past, it was common to use chlorine, but there are better options now. Instead of using the chemical to kill the germs in the water, they can be exposed to radiation that can just kill them and make water free of such infections. Disinfection method: lime can be used, treatment with oxone, chlorination, and UV radiation. These are just explained in details as you may see them. Tertiary treatment is additional treatment that follows primary and secondary treatment processes. It is employed when primary and secondary treatment cannot accomplish all that is required. What is it that is all required? Is dependent on the intended use of the treated water. So if you want to treat it to a level that removes all the pollutant to a high quality water end product. Then you take it through up to that point. So that is what determines that. For example, phosphorus removal may be needed for wastewaters that are discharged to receiving waters that are likely to become eutrophic or enriched with nutrients. So when you have nutrients in the water and they are discharged into the eutrophication is a process of growth of algae or green plants on water bodies. So when you look at some water bodies, you see plants are growing on top of the water. These are water that are infected with high-rich nutrients that can promote the growth of such plants. So the process is known as eutrophication, enrichment of water body with nutrient-rich materials or chemicals. Heavy metals, toxic chemicals, and other pollutants can be removed from domestic and industrial wastewater to an increasing degree that that will be safe enough for use. We have what is called methods of advanced treatment that include microfiltration, carbon absorption, evaporation, or distillation. So these are various ways that this can be achieved. Solid that settle out in the primary and secondary clarifier are referred to as sludge. We discussed that before. Sludge from biological treatment processes such as activated sludge are referred to as biosolid. Sludge is a byproduct of treating liquid wastewater. There are many different options available for solid handling, and we have discussed part of that. So that serves as part of our example. General categories of sludge handling include digestion processes, hauling of liquid sludge to a larger treatment plant, thickening or dewatering by mechanical means. So these are ways of handling sludge. Primary sedimentation and secondary biological flocculation processes concentrate water waste organics into a volume of sludge significantly less than the quantity of wastewater treated. But disposal of the accumulated waste sludge is a major economic factor in wastewater management or wastewater treatment. Method for processing raw sludge include anaerobic, which is biological digestion, and mechanical dewatering by either bed filter pressing or centrifugation. Conventional method for disposal are application as a fertilizer or soil additional on agricultural land filling in dedicated disposal site. I mentioned this as one of the end use of waste treatment, that the waste can also be taken out to serve as a raw material for the production of other products. In this case, an example, we had given this example of a fertilizer before. Then these specific terms are explained here, what stabilization refers to, what thickening refers to, and then dewatering and disinfection. These are just explained in detail. Sludge treatment process. We have looked at wastewater, and in the course of treating wastewater, we have the effluent that is discharged as water, liquid, and then the sludge that is collected as semi-liquid or semi-solid. Then that also has to be treated before it is discarded. These are various ways to ensure that there is an environmental friendly discharge of waste that is generated. So we move on to the next, which is the sludge flow chart, which is what we have seen here. The basic component, the plant inlet, which is from where or through which the sludge is introduced into the treatment plant, and then the various stages the sludge goes through. There's a primary stage and the secondary stage, and then the eventual product is given out as a plant effluent after final filtration and disinfection. So there's in the figure here, you see sludge disposer, a vehicle there to convey what has finally been given out for disposal. Then, sewage treatment processes, complete explanation. This is putting together the different aspects that are involved in the sewage treatment. And then you see it summarized in this chart. Disinfection by chlorine, raw sewage inlet, it comes in there. Coarse screening, that is when the big particles are removed. The fine screening, small particles are removed. It moves into the grit chamber where grit is also removed. Then clarifier, you move on, and the aeration tank, these connections, the summary presented here. Then I don't want to give you this as assignment, okay? I discovered because we decided that because my colleague has given you the assignment, we may step down this one. So this is what was intended for you to do, but you will not do it. Do that one so that your work will be lessened, except you want more work.
No.
What is your opinion?
No,
Thank you,
don't
sir.
want
Yeah,
to.
okay.
No,
You don't
we
want more
appreciate
work.
you for that.
That one is
Oh,
okay.
No, we don't want
all
more.
right. Okay,
We appreciate you
thank
for that opinion.
We appreciate you,
Thank,
sir.
thank you.
Thank you,
So by
sir.
this, I can say we have come to the end of this presentation,
Thank
and
you so much, sir.
hopefully, I think that this will help you in your understanding of this aspect of knowledge, as well as in the application in your various field of endeavor. Most importantly, the presentation will enable you to pass through the program successfully at the end of the day. Thank you.
Amen. Thank you, sir.
Any question?
Sir,
Any
when
question?
are we
Any
having the
comment?
material? Yes, sir, the material, when are we having it?
Okay, this material,
Yes, sir.
you have it just today on the platform.
Okay, sir. Thank you.
Okay, any
Thank
other
you so much.
question? Any other question?
No question.
No question. All right.
Thank you so much, sir.
I hope the questions are not because of a lack of understanding, but for clarity of understanding.
For clarity of understanding, sir.
Thank you so much. So we can call it a day. Have a nice time. We have come to the end of the presentation. That is to say, we have utilized our time maximally and spared ourselves tomorrow. Okay.
Yes, sir. Thank
So
you,
we'll no
sir.
more be meeting tomorrow, having
Are
concluded
we
it.
having lesson tomorrow?
No, that's
That's
what he
what
just
we
said now.
Okay, that
No
is at
lesson
least
tomorrow.
some people heard me right. What do you still want tomorrow?
No.
No, sir.
No,
So
sir.
we are done with the content. So I
Yes.
think we
Okay.
can take our time to study the material, start preparing ourselves ahead,
And do
Okay,
our
thank you, sir.
assignments. Thank you.
and do your assignment. Have a
Yes.
wonderful day. Thank you.
Thank
Thank
you
you,
so much,
sir.
sir.
Thank you, sir. Bye.
Thank you, sir.
All right, bye. I can stop sharing now, and then I can end my presentation. And that's it. Bye-bye. Thank you.
Thank you, sir.
Thank you, sir. Class rep. Class rep.
Yes.
I don't know. Were you able to go on the Tuesday like you said?
No. I went, but the woman wasn't on seat, so I'm going tomorrow in the morning.
Okay. And what of the numbers that we're looking for? I don't know if you were able to get for us.
Which numbers?
I'm looking for Professor Namonu's number. She's my supervisor.
I've not gotten. Even my own supervisor, the name on the timetable is different. The name, so I don't know whether it's exact distance. So I don't know. That was why I asked yesterday who is sharing the same supervisor with me, if he or she has been able to get across to him.
House rep.
Yes, sir.
Good morning, sir.
I got
Morning.
that guy.
Sorry, my is Professor T. Vange. I don't know. How can I get a number?
Did you check the
Professor T.
timetable?
Vange. Yeah, I checked now. Professor T. Vange.
Is he on the timetable?
Yeah, it's on the timetable.
You can get the details there now. His phone number and email are there.
Okay. I'll try and check.
I got a piece. I'm still talking to that guy. Let me send their timetable, their master's timetable. Then if you send, I will send it to you, Gata, please. I'm still chatting with that guy.
All right, thank you.
Yeah.
Okay, now.
All right, bye.
Thank you, everyone. Yes.
Good morning. Is it late to submit via you student of conduct?
That is what Agatha just asked. I have not gone.
So is it late?
It's not
It means
late.
no.
Okay. I private chatted you already about it.
Okay.
All right, thank you.
Welcome, sir. Well, Nato. Good day, everyone. Yes. I can't hear that. Your network is breaking.